you want to?
Yeah. Let's get started. Okay. So it is great to see so many people interested in great graphics to explain the tough concepts that we all work with. Welcome from the entire Project StaSIO team. This is our first ever webcast as we build out the Knowledge Hub side of the Project StaSIO website. This will include a YouTube channel that has videos like this on it and how-to guides on creating useful, readable graphics. So it'll be built out over the next couple of years, and this will be the first piece of it. We have other sessions planned somewhat monthly. So in addition to hosting competitions and great graphics, we're also delving into how to create graphics, distilling very complex simulation data so that even architects like me can understand them. So there's a quick poll you can take, and I'm going to share that in just a minute. So my name is Chell Anderson, Director of Sustainable Design at Element Architects in Seattle, and I get to be the MC today. So basically this session we hear from 7 folks who have been crowned by the illustrious panels of judges we've had over the years. You will hear why and how they created their graphics in a sort of a speed dating way. Each will talk for 2 or 3 minutes on why and how, and then I will ask a follow-up question or 3. If you put a question in the chat, I may ask that as well if I see it. Once we get through each of the presenters, we'll open it up to additional dialogue between everybody. So that's what we're going to do today. It is being recorded for posterity and others who couldn't make it right now. As always, please mute yourselves if you're not presenting. So grab some popcorn, sit back, relax, and without further introduction, we are going to share the poll and then start with Aman. So let me do the poll. Where did the poll go? Where's the poll?
I can end it. Do you want me to end it?
Yeah. Can you end the poll and then share it with everybody? All right. So a lot of you are in a building simulation. Some of you are architects, engineers. We have not a single mechanical engineer in the house, in the virtual house. And we have 1/4 of your students. Nobody's teaching stuff. And then a bunch of you are other. So that's interesting. Some of you are new to StaSIO, welcome. And most of you have only been there once. So it's a great resource. Please use it more often. And some of you are monthly users. That's great to see. And then nobody says there's no great resources. That's awesome. I love to hear that on how to prepare simulation graphics. Looks like I search the internet is the #1 way. And then Project StaSIO is also tied for #1. So that's what we like to hear. And the team, the StaSIO team would love to hear feedback on how to make it better as well. Okay. All right. So without further ado, Aman, do you want to talk about your winning graphic? The why and the how?
Yep, sounds good. Hi, everyone. My name is Aman Singhvi. I'm based out of New York, but currently I'm in Germany, and it's nighttime here, calling in from there. Just quickly about this graphic. So this was made all the way back in 2016, and this was the very first step to a multiple analysis where we also did radiation analysis. And this was, as many of you can tell who have used Ecotech, this was like an ode to Ecotech, but it was like, made using that kind of graphic style. And basically the concept for this graphic, the need for this graphic was that it was important to separate the morning and evening shadows distinctly based on the program and the time of the program of the surrounding buildings. And this was for this community park space in a very cold climate. The programs surrounding the buildings, some of those were elder housing, some of those were universities, and there's different community accesses. So everyone uses the park at different times. So we took this approach of creating this 2 shades, morning and evening. If you see on the bottom right-hand side, those are actually separate AM and PM shadows and their percentages. And the idea was that we wanted to have a clear idea of how the program can be subdivided based on different building groups and how the landscape can be designed. Where should we put the parking space? You know, where there's always shade, we can put the parking space and all that stuff. So this was actually a series of animations. So all the images on the right-hand side, the 3 images, are part of the 3 mashed up the points that we do analysis on. But this was like an animation of individual hourly images as well. Real quick on how this was created. So this was created using Photoshop and mashup of individual hourly images from Rhino and Grasshopper. And we also were able to pass the script back into Grasshopper image recognition to actually get a point value of each. So you can okay, is 5 somehow.
I don't know if everybody else is also losing Aman, but I am.
Yeah, I am too.
Bummer. All right. I think what the judges liked about this was that it's a fairly simple concept. What is the range of shadows across a day or a season, or within a season? But the innovation is using 2 different colors and to express the morning and the evening. So I think it's simple, it's clear, and I can say we've actually used this concept since we saw this graphic at LMN, because it's really compelling visually, but also in terms of the information is a lot better than just a simple shadow range study that we've often done before. Since we can't hear Aman, I'm not going to ask a whole lot.
Aman dropped off, unfortunately, so hopefully he'll join in a little bit again.
Okay, we'll have to overdub some of his stuff. Okay, all right, we are going to move on to Misha. Do you want to talk about your graphic?
Yes. You guys hear me? See me? Excellent. So this graphic is for the New Canaan Library, which is a project that our firm has been working on for a number of years, but is actually going to be completed and opened in February. So we can't wait to see if the daylighting predictions really come true. So the need for this analysis came out of a VE exercise. We had this large daylit space with a clear story that was going to be very magical and light-filled at the heart of the library. And with VE and getting rid of the basement, we had to put all our mechanical up on the roof. But we really wanted to not lose this amazing feeling of natural light. And so we decided we're going to compromise. We're going to put skylights in between the heat pump units and hope that we can still get a good amount of daylight. Instead of just hoping, we decided to put it through Ladybug and try and optimize, and then working, of course, with the mechanical team to make sure the units still fit. It was like tolerance of a few inches. They made it work, though. So you can see on the bottom here, we tested out a bunch of different scenarios. Sort of 2 questions we were trying to ask with this modeling. One was, how does the width and distribution of skylights change the distribution of daylit area? And then 2, is there any useful aspect to these baffles? We kind of intuitively felt like angling the ceiling so that the skylight light could reflect could be helpful, but we wanted to model it to be sure. So you can see on the bottom is in orange here. Those lines are representing the glare for each scenario. And in blue, that's representing the spatial daylight autonomy. We use 200 lux, which is less than you would use for an office, but that is the amount you would use for a library space. This is really like a reading hangout room. And we wanted to be sure is that even as we're providing this excellent daylight, we don't have a ton of glare that's coming through. So you can see on the very left, the scenario with the 5-foot skylights. Those skylights are very wide, and even though they are deep wells, still, especially during the summer, the sun comes right straight down through them and causes a lot of glare. So we didn't want that 90% glare, even though the daylighting was great. And on the very right, the 2-foot skylights were too narrow, and only half of our area was daylit. So this let us kind of find this Goldilocks scenario, the 3-foot skylights that seems to have worked out pretty well. So if you go to the next slide real quick, of course, this is how the analysis and data actually looks. It's, this very messy Grasshopper script with all the different services assigned. And then, of course, the representation of it, we work in Revit. So we had to build sort of a dummy model in Rhino and assign all the services in there. So this isn't all that exciting or shareable. So the key was really, how do we take all these scenarios we've run and represent them in a graphic format? That was kind of the fun part of this exercise. If you go back to the main graphic for a second, you can see eventually we took a section perspective in Revit and then dropped a perspective view of the daylighting grid that came out of Ladybug in there. And in layering that over, I think it helps to illustrate what's actually going on in the space a lot better. And then showing all 5 of those scenarios again in that perspective view. It's not a standard way that we visualize daylight grids because we usually think of them in plan view or AXO. But we found this to be convincing, and it also really tells the spatial story of what this living room space feels like. And then final thing I'll sort of mention is 2 pictures ahead. So that's a space under construction. And as I said, it will be opened in a few months, which is really exciting. But even now already, you can see there's no artificial light that is being lit in the space. The skylights have been installed, and the daylighting is really fantastic. This is the middle of the day, so the sunlight is pretty, coming directly from the top. So the baffles are fairly shaded. But the light is clearly reflecting in those wells of the acoustic plaster. And by the time you get down to the floor level, the light is pretty evenly distributed. So we're going to do a lot of photometry on this when it opens and hopefully confirm our results. But so far, so good.
That's great. I've noticed that when you can go into a space and take a regular iPhone or whatever photo of it without any electric light and it looks good, that's really well daylit. So that's awesome that it actually works out that way. So do the sawtooths, do they face south or north or east or west?
It's southwest.
Southwest. Okay, so they're really actually absorbing the sun, or they're not trying to avoid having direct sun into them. They're actually facing that direction.
Yes, that was very much the intention. And with designing the width being 3 feet, you never really get direct sun coming in, but you always get it reflected off of that wall on the east side.
Yeah, I like the fact that you did use the perspectives. I think that aligns with the 3D model a lot better. That's really a cool way of doing it. And then 200 lux, I think that's a really good choice as well. Is the living room, is it a space for people reading? Is it kind of just a circulation lobby? What's the purpose of the living room?
Yeah, so you can kind of see on the bottom right is the entrance lobby that people would come into the library from, and they kind of circulate up through these levels. So the living room is a kind of pass through to get up to the adult and teen library on the higher floor. But at the same time, it's got couches, it's got a fireplace. It's a place people to kind of hang out, read magazines, or maybe iPads is what people read now. But 200 lux is actually a good level for both screens and reading. So.
Yep. And when you say 3 foot or 5 foot skylights, is that the width of the skylight from side to side, or is that the height of it? Or
that's the width of the skylight. Yeah.
Okay, cool. And it looks like they're also fairly tall. Did you?
They are
as well.
Yes, and that was, of course, partially a response to the mechanical units. We wanted you to not be able to see the mechanical unit through the glass when you're standing under it. So kind of looking through those sight lines. That and sort of just the curb height around the mechanical units kind of started determining that.
That's great. Cool. Well, let's move on to Macha. Macha, are you ready to talk about your graphic?
Sounds good. Hi everyone. This is Macha Bhargav. I'm currently working as a senior analyst with Environmental Design Solutions based in New Delhi, India. I have submitted this graphic for the project StaSIO 2021 Summer Challenge, which focused on daylight and glare. And this was a part of an academic exercise when I was pursuing my master's in building energy performance from CEPT University, India. So this was an academic exercise, I repeat. So here, this analysis was done as a early design decision-making process, which was an imaginary scenario. And this analysis was done for a housing, one typical unit in a housing block in an Indian city, Ahmedabad, which has a hot and dry climate. So in such climate, daylight design can be challenging due to the conflict in trying to minimize the incident solar radiation, sorry, on the facade. So here through this graphic, I tried answering a simple question, which is, what is the impact of orientation on daylight performance and, irradiation on the facade. So here this graphic attempted to show the relationship between daylight performance and the irradiation of the building that I just talked about. And as a conclusion, this orientation optimization was found to impact both daylight performance as well as radiation in a desirable manner. So while making this graphic, the first thought that popped up was, who am I presenting this to? Assuming that this presentation would be made as a part of a design charrette at the early design stage, so that group of audience would comprise of both technical as well as not very technical people, such as the clients themselves. And if we look at the bottom right side of that graphic, ideally speaking, to communicate it to a technical person, that simple small rectangle would have been sufficient, which shows a scatter plot between the, that shows a relationship between a facade radiation and the daylight performance. But the rest of the graphic, it was more targeted towards the architects and clients who would understand this better when they see it. I have used Ladybug tools and arranged the result in PowerPoint. So here, if you see at the top, these 4 blocks, I mean, it's the same block, but 4 different cases with different colors that represents the irradiation on the facade of that particular unit. And then correlatively, the floor plan, which has the percentage of floor area that meets less than 90% UDI between 100 to 2000 lux. So that only that part which meets at 90% of the time is highlighted in red. The rest, everything is just plain. So this just drives your eye directly onto the only colored part in that floor plan. I think that was a very simple intervention I did with a typical output that a Ladybug tool gives, which has a color scale with so many colors for every interval. So ideally for me, I did not need that part of the floor area which has a UDI of under 90. So I think that makes it simple to look at and easy to understand.
Yeah, thank you, Macha. That's great. I love that it's a rich graphic. It's very complicated as you explain the different parts of it. But it does, just the big red facades versus the blue facade it's just really easy to read what's better and what's worse, and having large keys that are actually readable is extremely important. I love also that you chose the 90% UDI for success, and then made it simple to see if a rotation met that 90% or not. And you can obviously see from left to right that how did you choose 90% as a metric for success? Is that a standard metric, or is that something that the team chose?
Exactly. No. So the Energy Conservation Building Code of India specifies that for each building category, it has a a prerequisite that a certain percentage of area should meet this area requirement of 100 to 2000 lux for at least 90% of the daily towers.
Oh, so it's a requirement in the code.
Yeah, it's a requirement. Yes.
Well, that's great. And so this is obviously not just a like how to design better, but how to meet the code kind of graphic as well.
I mean, in fact, codes are designed for that same purpose.
I was also noticing it appears in the graphics, like there's little screens inside the windows. Was that part of the design as well?
Yes, that was a part of the design.
Yeah. Lastly, how was this presented to the client? You mentioned it was presented to non-specific user, energy simulation folks as well as some more savvy people. Do you know how this was received by the client?
Not really. I never followed it up since it was a part of the academic exercise. It was not a real-time scenario, though the building is real-time. It exists, but
Yep. Okay.
This was an imaginary scenario.
Well, this is the kind of stuff that our industry needs to be presenting, because it is compelling and easy to see what works and what doesn't. Cool. Thank you, Macha.
Great. Thank you, everyone.
Guanzhou, are you ready?
Yes. Hi all. So I'm Guanzhou and a PhD student at the Carnegie Mellon University. My project focused on residential daylight. For living space, we can easily simulate daylight and get a result from different daylight metrics. However, human has different indoor activities like sitting, cooking, or reading. The big question here is, how can we design the space for multiple tasks? Next, please. Next page, can you? Oh, sorry. Yes, thank you. Here I selected 4 living units with the same unit size, but different orientations and fenestrations. Then I only outlined 3 main areas, area 1, 2, and 3. The local light level changes with the distance to window, and the 3 columns show the result of annual daylight pointing time result under different sky conditions. For the upper 2 rows, for the north unit, the light level also shows difference between the overcast sky and the clear sky condition. For the south unit, the light level actually changed a lot under different sky conditions. And I focused on the raw data, and the density of data points tells us the distribution of illuminance values. And next, please. Yeah, another study I'm doing recently also focused on residential daylight. I do light measurement in the real world. I firstly capture the indoor panorama with photometric calibration for an empty room, then study functional layout. Here, furniture object will be automatically placed into the images with the rendered appearance, so we can visualize the entire indoor space without modeling building geometries. Yeah, that's all. Thank you.
Thanks, Guanzhou. That's great. So this is built now, and you were able to go out there and actually test it? Is that?
Yes, for this one, I focused on existing building. Yeah.
Yeah. And how did your testing match up with your your analysis? Did you find areas where I've seen post-occupancy evaluation where you go and you see something and then it's very different than what you thought based on something you didn't put in your model. Did you find anything that wasn't in your model that was important?
So first, daylight simulation is important, but in the real world, we always have the gap between simulation and the real world. So what I want to test is that we do simulation. We use task area to outline the space for sitting, cooking, whatever, but we also need to validate our simulation result. Here, I use the real photometry techniques and just to test whether my simulated result can work or not. Yeah.
Yeah. So this is a really rich graphic that has lots of colors, and I think a lot of people would it takes a while to understand what is going on in the graphic. But I love that it is actually looking at a significant design change. You know, some of the graphics we look at are whether the shading device is 2 feet deep or 3 feet deep or something like that. But this actually looks at a radical layout of things. What if you were to tell me what the top 3 things I should look at within this graphic are? What would they be? The most important things to look at to understand the difference between the 4 designs or the 4 layouts.
Yeah, that's a really good question. Okay, I will make an annotation. So first, there are 4 living units in parallel, but more importantly, it's the distance to window. For living space, the window is the only channel for daylight, especially the side light. So we want to see how the light drops. But actually, for some designs, the light increased because fortunately, we have side light window. Right? So it helps us to see whether the side window is effect or not. And for daylight, typically we need an annual simulation to conclude how this space looks like in terms of daylight. But for the extreme condition, we also need to focus on point in time. And this simulation is actually in Seattle. We know Seattle is cloudy, you know, but actually there is a slight difference between the north-facing unit and you see the upper threshold is slightly different. Yeah. Yep.
Yeah. So is this, I guess, is this the result? So you have different layouts in here, but they're based on different units. So did you just show the optimum layout based on each of these, or were there more analyses that you did to get to this optimum layout or best layout for each of these?
Oh, I see. So when we do daylight simulation, we have 4 sensors occupied with the entire space. And then I use data selection and only select those 3 regions. So that's why we can see those 3 colors. And then because lighting handbook actually can give us the target horizontal illuminance level. So if we draw some benchmark, maybe 200 or 300, then we can use that to see whether our design is working or not, sorry. Yeah.
Cool, well, that's great. Thank you so much for submitting this. And it's really interesting to see all the different ways of looking at daylight. You know, we did the daylight simulation challenge, and we had lots and lots of entries that were all vastly different in the way they approach daylight. So this is a cool and innovative way of doing that. All right, Tarjani.
So yes, so hello. This analysis was a part of a classroom exercise carried out to evaluate how building envelope design parameters and natural ventilation potential influences the energy performance of the commercial building in a hot and dry climate of Ahmedabad. So the building was a hypothetical building. It was a commercial building based on the ECBC code, which is an Energy Conservation Building Code of India. You guys can hear me properly, right?
Yes, we can.
Yeah, all right. And this exploration was to understand the impact of natural ventilation on thermal comfort of the occupants, as well as the reduction in the energy usage of HVAC systems. Now, the assessment was performed for all the zones of the buildings. Now, as per the defined, when you look at the graphic, now as per the defined window operation control logic in Energy Plus, the model adjusts the window opening ratio, and the effective aperture ratio set in the design builder is 0.9. Now, to maintain the zone air temperatures, there is a reduction in the overall HVAC energy consumption by comparing a base case, which is fully air-conditioned space, with a fixed static set point, and one which is a changeover mixed mode integrated with natural ventilation and AC operations, and having a weekly floating set points. This resulted in a reduction of 62.5 degree energy savings. And the India model for adaptive comfort was referred to arrive to this 90% acceptability thermal comfort bands. Now, in designing this graphic, it was essential for me to demonstrate impact of natural ventilation in a simple yet effective way, so that it can help the designers to pick and choose as to what needs to be focused on more. So this graphic also attempts to portray that the impact of integrating natural ventilation into annual HVAC energy usage and the thermal comfort of the occupants is essentially important. Now it starts with the carpet graph to show that the window opening, what is the change in the window opening factor, then what is the air change per hour, then the energy consumption for each hour throughout the year. It's a carpet graph. And in this model, we can observe that the window opens when zone air temperature is greater than T set point, zone air temperature is greater than the outdoor air, and the availability schedule is 1. It also aids in removing the accumulated heat and hence helps in maintaining the internal set operative temperatures. This graphic further tries to portray the impact of natural ventilation in all the zones over the building, which I've shown in different ways, and how each zone will have an impact, how each zone will have a different impact. And the dial on the right displays the performance of window operation, annual saving, and the number of met hours. It also tries to demonstrate that for a given climate, this passive design strategy has significant impact on the system performance in the buildings. And when we look at the degree of unmet hours, we can also observe that it attains the occupant's thermal comfort in a very desired manner. Thus, this graphic can more or less help the designer or an architect in comprehending to these aspects while designing in a very planning stage, and it can enable them to take data-driven decisions during the early design stage. So yeah, this was the thought behind it.
Great. So were you involved in the project after this analysis?
Not on the same building, no.
Same building. Okay, yeah. So you.
It was a classroom exercise and a hypothetical building that we looked up.
Yeah, well, it's great. It's interesting because you're presenting a whole lot of data on one sheet, and somehow it does all tie together. And you can see the annual window opening factor and the air changes per hour, and that is for the whole building, right? Not just you break down north, south, east, west, and core later, but then annual window opening factor and air changes per hour. That's for the whole floor plate, right? Yeah.
Yes.
Yep. And then further you break it down. So you're using the left to right annual window operation. Then you go to the right and you see the zoning, and then you go down and you see the energy consumption per the zoning. So that's really interesting. And then the degree of unmet hours is based on what percentage of the unmet hours are.
No, the degree of unmet hour is like if there is the 10% of the hours were unmet hours. So then the analysis goes into in that 10%, 60% of the time the degree of unmet hours is only 1 degree.
Mm-hmm.
There is 1 degree difference from the comfort band that you look into it. So that is what it tries to show, that the maximum amount of the time, the uncomfortable hours, but that 60% of the time, it's only 1 degree above the comfort band, which can be adjusted. If we further look into it and further analyze it, it can be adjusted.
Mm-hmm.
So what this tries to explain.
Yeah, and so this is assuming no mechanical system, right? Or no mechanical cooling?
No, it's in a mixed mode. So
okay, mixed mode, yeah.
It's in a changeover mixed mode. So when natural ventilation is on, the ACs will be turned off. It's a PTAC system that I've assumed for this analysis. So when natural ventilation is on, when the windows are open, the AC is completely shut off.
Mm-hmm.
And
then
when it is, sorry, go ahead.
And then the unmet hours are when the mechanical system would turn on.
It's all over the year with natural ventilation as well as AC. When it's working in a mixed mode for a whole year, how much unmet hours it's covering. And if in that unmet hours also, there's a further segregation as to in that unmet hours, it's only 60% of the time, it's only 1 degree difference from the comfort band.
Mm-hmm. Are these direct outputs from the software that you use primarily, that you composed into this graphic? Or
no,
it's
a post-processed data. It's a post-processed data. So we get a lot of data from Energy Plus, Design Builder, Result Viewer, and aggregating all of that data in Excel.
Mm-hmm. Okay.
All of this is made in Excel.
Okay, yeah, that's also really interesting. When you have different tools, the graphic outputs of them are vastly different and sometimes not very great. So That's great that you put it all in Excel so you could correlate the data.
Yeah, to collect the data, it's an Excel sheet, and then I've composed it in InDesign.
That's great. If you had more time on this, what would you have done? Would you have done anything, or do you think it's?
If I would have much more data, I would have tried to analyze personal comfort systems, because it's very in right now. So, when you are in a mixed mode, and if you have only this much, then it's an office space. I would have tried to analyze if, I can try, if this 1 degree, 2 degree, the discomfort hours, if I can manage to personal comfort systems. I would have tried to analyze it further. In that sense, in thermal comfort way, I would have tried to analyze it more.
Great. Thanks, Tarjani. John, you are up next.
Okay, great. So this graphic, as you can tell right away, is quite a bit simpler and more straightforward, and that was very intentional. What we looked at here was the impact of different energy conservation measures on a building's annual energy costs. What we did, and really why we were trying to do this, it was in very early design, orient the different team members, including the owner, to different strategies we could consider to help move the needle on energy performance. So this was done at a shoebox level as a sensitivity analysis, and really just throwing a bunch of different strategies at the wall and seeing which one would stick. What we did was take the graphic using the results from Sapphire, but we could also do this in other programs such as Net Energy Optimizer. Take that as a CSV file, plug it into a very complicated program known as Excel, organize it with the different end uses that you can see color coded there, whether that's HVAC or lighting, plug loads, etc., and then just rank order them by their impact on the energy bill. So the longer bars here are essentially greater energy savings. You can see the x-axis is showing energy savings as a percentage. The reason we organized it this way is really twofold. One, we wanted it graphically to be very approachable to lay people. We didn't necessarily want it to convey a lot of information and a lot of complex information, just really simple, orient the team to the big picture things we needed to think about. And also by showing the different bars, so we have both solid bars and shaded bars. Those kind of represent the minimum and maximum savings potential of different strategies. So as part of a sensitivity analysis, we're kind of saying, well, the maximum savings, if we do additional roof insulation, might be as low as this or as high as this, depending on what we kind of felt were the practical minimums and maximums. So this actually resides in PowerPoint after we exported it from Excel. They could also just stay within Excel, but the reason it went to PowerPoint is this is really part of a team meeting where we wanted to talk about, if we have a certain energy use reduction goal, how do we get there? What are some of the strategies we're considering? And this really helped us to sort of see, and in terms of the different colors, that the envelope strategies in blue for this particular project in Climate Zone were not going to be as influential as, say, some of the team members thought. As I'm sure many of you have worked with different folks, there are lots of different perspectives, whether that's the architect, the engineers, and whether that's a mechanical engineer, electrical, or others. So sometimes we all come with our kind of inherent interests and biases, and this is really a quick way to kind of say, for this particular building that we're working on, here's some of the things that we need to look more closely at. Here's some of the things that don't seem to be shaking out. And then we can obviously go and check behind these numbers to see why are they happening. So that's what I wanted to share. I'll share kind of one caveat that this is a great way to look at strategies in isolation, but it's important to obviously bundle strategies together after we've got some owner direction to see if there's some trade-offs, because these, of course, aren't additive. Unfortunately, the more you do, you hit the point of diminishing returns. So it's important to do that analysis as well.
Yeah, that's great. Thanks, John. I think that's a really important caveat. And then there's obviously a design, mechanical design, and envelope design. I think it kind of goes along with this. What is the baseline? What is the thing? I think sensitivity analysis is one of the most powerful things and that we can do early in design. And I love how simple it is. I feel like most building owners could look at this and at least they've seen something like this before, and so they can begin to read it, which is really awesome. And then as Alejandro said, horizontals are nice because you can get the text right next to the bar instead of having to read sideways text or text that's cropped in there. Yeah, I think it's so simple. There's not a whole lot of follow-up. Do you know how this was for an actual project, right? Do you know if this was presented to the client? Were you part of that presentation?
Oh, absolutely. So yeah, how did it go? Yeah. I tended to do this kind of graphic quite a bit for different internal team meetings, and then also with the client to just sort of say, if we've got some model results, here's what we're seeing. So this was really the result of kind of several iterations. Didn't start with it being in this format, and I actually did have it as a vertical columns instead. And for the reasons you pointed out, that was a lot more difficult to read. So that was a good comment in the chat. So yeah, this kind of graphic I've used quite a bit. I've kind of adapted it over the years, but it does kind of provide a frame of reference as we're having initial conversations about what kind of things we should pay attention to.
Yeah, and then I think, with all graphics, the first thing I look at is, is there a conclusion I can draw from it by looking at it? And some of them it takes 3 or 4 minutes to get a conclusion. And this one you can say, okay, energy recovery, lighting power density, or receptacle power density are probably the best strategies. So let's talk about those, and maybe talk less about solar heat gain coefficient and some of the other things. So, yeah, and I didn't point this out, but all of these strategies fortunately had a payback period of 10 years or less, which was kind of why we put them in the mix. There were some others that we didn't show on here that were either very long payback or they just had so minimal savings that you couldn't see it. So this is still a filtered list, but does kind of show a bunch of different possibilities in one place. Yeah, and the last thing I'll say, and then we'll move on, is that showing non-specific outcomes or showing variability is something that we struggle as an industry to show. Is we can say this is the EUI is going to be 43.79482, and we can be and we're not showing how wrong we think we are or what the variability in accuracy is. And this begins to show that in a simple way. So I think that's another positive from this one. Good point. Thank you. Thanks, John. Kevin, we'll move on to you, and then I will show your animated slide whenever you're ready.
Great, thanks. Hi, everyone. My name is Kevin He. I'm currently at HDR. At the time of making this graphic, I was with SQ Dumas Ripple in New Orleans, and you'll see that kind of mentioned in the graphic. So my graphic is looking at what is the impact of current window wall ratio and louver material on lifetime carbon and construction costs. So as you can kind of tell from the title, we were trying to tackle a lot of different factors and outcomes. And the reason for this is we actually had a tool on the back end. So similar, like a lot of other people who had presented today, we're using Grasshopper and Excel data to kind of drive some modeling. And we wanted to produce an actionable graphic that could sum up a lot of that information for people who can't script or who aren't familiar with it, so that they could arrive at conclusions without maybe needing to open up a Grasshopper file. So what you see on the left side of the graphic with design variables, it's formatted similar to how you might see sliders in Grasshopper, but those are really the constants we're looking at. So like I said, our location that we were interested in was in New Orleans. And there were a lot of buildings where we were uncertain how louvers made an impact on both the overall lifetime carbon as well as on the construction costs. So the kind of the data that we're portraying here is looking at almost every combination of that information, and you can start to arrive at some interesting insights. So first up to the right of the design variables, we just start looking at very basic information like offset time. So carbon offset time being at what point does the embodied carbon of the louver material outweigh, it gets outweighed by operational savings. So that basically tells you, yes, you're going to produce carbon manufacturing louvers, but at what point does the energy savings offset that initial carbon cost? So for no louvers, you're never going to have an offset. Aluminum louvers, your offset time would be at 30 years compared to having no louvers. For wood louvers at year 5, and same thing for glass louvers. So just starting off, we're looking at materiality and offset time. from there, we realized there's actually so many more variables that we really wanted to keep track of to really empower people to make a decision. So first up, we're looking at total lifetime carbon costs. And one thing that kind of came up again and again is most of the time it's not as simple as just picking, oh, are you going to put a louver or not, right? As a designer, you have a lot of options in terms of how you might design the facade of a building, including window wall ratio. So we kind of began the ambitious task of trying to plot all that data on this one graph. So the graph you see on the right, it's broken up by different window wall ratio breakpoints. So window wall ratio just being, the ratio of facade fenestration you have to solid material. And as you might intuitively think, at 100% window wall ratio, when it's all window, you're going to have the most total lifetime carbon costs, no matter what type of louver you have. At a low window wall ratio of 10%, you're going to have the least total lifetime carbon costs. Construction costs we're also tracking just because a lot of times if you don't have a number to it, people aren't interested in talking, right? So you can see more expensive louver materials like glass will increase your construction cost per facade. And the interesting kind of novel insight that we got from this is that there's different material in window wall ratio breakpoints that we can start to use to kind of flex between designs. So for instance, if you're targeting a total lifetime carbon cost of 400 pounds of CO2 per square foot, right? You could be using a 70% window wall ratio design with wood louvers, and that would be equivalent in carbon costs to aluminum louvers on a 60% window wall ratio design. So before in the past, we might be stuck doing simple one variable analysis where you're saying, okay, well, wood is going to be less carbon than aluminum, right? So let's use that. But here we can actually see if you change your design from 70% window wall ratio to 60% window wall ratio, that actually unlocks other materials for you to use. So that's kind of just one example of what conclusion you could drive at this specific graphic. And Xiao, if you could go to the next slide. So something that obviously is on the back end of the tool is there's a whole lot more at play. So the idea for the graphic is for people who are interested, there's this whole back end you can explore. So on the right, you have all these variables. So you can start to be very specific about your site conditions, the facade dimensions, the louver dimensions, different carbon costs, which is going to change over time depending on where you're getting your materials from. And on the left-hand bottom side, you can start to see also throughout time what it looks like. So in the StaSIO graphic, we had to submit a static JPEG, but there's actually this animation that we had made looking at that offset time plotted next to all the window wall ratios and carbon costs as well. So kind of that GIF is a more advanced version of that graphic for looking at throughout time how your design decision is going to impact carbon costs and construction costs.
Cool. Thanks, Kevin. So was this presented to a client at some point?
So this was actually mostly internal, which is why I think we had a lot of flexibility in catering our specific insight that we wanted to arrive at. And the goal of it was to really produce a graphic that designers who maybe had no experience in doing any type of simulation could kind of just pick up and use. So for this one, it was useful for people who were working at the firm in New Orleans, and a lot of our projects were in New Orleans. So they could take some of this insight and repeat it across maybe a couple other projects just as kind of guidelines.
Mm-hmm. Yeah, so there's a lot of complex information on here, and it reads kind of left to right. Left, you have the payback time of the louver type. Mm-hmm. And then on the right, you have, well, on the left, you have the design variables, which I assume was how you selected these things in Grasshopper. Is that
right? Yeah. So those were the constants that were fixed for this specific graph iteration. And as you change those inputs, you're going to get a slightly different looking graph.
Oh. And then on the right, you have these kind of, flying bird shaped graphics that so if you were to present this to me right now, and you said, focus on these two pieces of it, because that's the optimum design, what would you want to highlight for the graph on the right?
on the graph on the right. So like I was saying with that example, I think the big takeaway is that we're not limited in one variable, even though a lot of times the graphics that we're producing only chart by one dimension at a time.
Mhm.
So like when we do analysis in Devo, right? Like you have to input, you know, at least one design model. And if you change design models, you're going to get a different chart. But if you change too many things at once, you can't just plot it in a linear line, right? You have to show those variables changing. So I think that's, so like I'm seeing the question right now, why the window wall graphics are different widths. So there's a lot of variables at hand when we're changing multiple at a time. And the graph on the right is trying to show between material and window wall ratio, you can already get such a rich difference in scenarios that leads to kind of new opportunities where you could look at a facade, let's say that's like 80% window wall ratio, right? And the fact that it has an identical lifetime carbon cost, carbon footprint of a 90% window wall ratio with glass louvers, I think is very exciting, because now you have a way to go across these variables and be able to justify them and say, hey, guys, we can make our facade more beautiful with more glass and not at the detriment to the project carbon-wise. Cost-wise, it might go up, right? But that's the other axes that you can start to consider and justify design with.
Yeah, that's really interesting. I think it's also really interesting that you brought a cost of carbon into that for the vertical axis on here. Is that something you're talking more about within decision making for project teams?
Yeah, so the big goal of this too is to look at embodied carbon in addition to operational carbon, because especially for things like louvers, it's a pretty substantial part of your design if you're going to be manufacturing for large scale facades. So at the time, I think we had seen other teams do analyses on operational carbon, right? And we really wanted to be able to add in the total carbon cost. So that's including the embodied carbon, to be able to, you know, fully justify and say without caveats, like, oh, by the way, there's, you know, some embodied, but, you know, over time that gets outweighed. We wanted to show that instead of just verbally saying that's happening.
Yeah. Great. And then this was all produced in InDesign, I assume, with some support from exporting of things from other software.
So the graphic was actually made in Tableau, same with the animation on the next slide. And yeah, Tableau we found to be the easiest, I guess, one-to-one translation of kind of the Excel data. Like essentially with Grasshopper, we were able to run with Galapagos a bunch of different iterations and then output that in a raw data, take the raw data in a Tableau and graph it in this, what you see here.
Cool. All right, thanks, Kevin. Aman, do we want to go back to you? Are you around?
Yeah, sure. Apologies for earlier. Hope you're able to hear me okay this time.
I think we heard the presentation pretty well. It was just the very end of it was
okay.
Challenging.
I'll do a quick 20-second recap. So yes, thanks you. So this was made as a part of a series. This was a point-in-time shadow study, and there was also a separate radiation map created for this. This was essentially made to separate the AM and PM shadows to accommodate the needs of different programs, and to see where to put parking, where to put landscapes strategically based on, you know, elder folks using this versus other folks using this. How it was made. This was made as a circular workflow from Rhino to Photoshop to back to Rhino. And it was using individual shadows out of Rhino, Grasshopper, into Photoshop for batch processing, and back to Rhino for like pixel analysis generally. And essentially this became part of an animation as well. Nothing complicated here to answer, nothing complicated here to analyze. This was just one image created as part of multiple analysis for this community. And I think, yeah, I think we, at the time when I submitted this to StaSIO, this was one of the first ones. This was back in 2016, and decided to tell the story of this community through this image. Yeah.
Yeah. And was this presented to a client or was this used internally? And if so, how did the results come out, or how did the resulting design reflect this analysis? And
So this was apologies. Yeah, this was presented to the clients as well as internal, and this was also presented to some stakeholders, and I think it was received quite well, especially along with the animation. Yeah, but I think there was some different directions regarding sites, and this was just early analysis that didn't quite make it through because there was some situations that changed with the site boundaries and things like that, and there was some issues with the developers as well. So yeah. Anyway, but it was successful in telling the story we wanted to tell, and especially the individual images at the bottom right for AM and PM shadows helped to design some of the landscape seating areas and things like that.
that's great. Thanks, Aman. Well, that takes us through all of our presenters. I do want to announce that we are having a discussion. As I mentioned, this is part of a new knowledge hub part of Project StaSIO, and we are going to have one in mid-January called the Windrose Debate that Alejandro will be emceeing and organizing. We're going to have a bunch of people talk about windroses, and Ale, do you want to plug that?
Yes, for all those of you who are picky about windroses, who have strong opinions about them, or who have never thought about why you should have a strong opinion, please join. We're going to have, we're still finalizing the panelists, but we're very excited to have that discussion. It's something that, in my experience, I talk about windroses all the time. I have very strong opinions about them. And so I would love to hear your strong opinions too. Please join.
Cool. All right. So you'll see something from Project StaSIO and on LinkedIn and probably through the same channel that you got to hear. All right. Are there follow-up thoughts anyone has, questions anyone has for any of the panelists, or further thoughts from the panelists on anything? This is just an open Q&A time. Unmute yourself, put something in the chat. I know it's scary to do that, but
I'll have a comment while others that unmute and ask, but it's quite impressive now seeing these graphics one after the other. We've seen them many times, at least within StaSIO, the StaSIO team, but we talk a lot about your 30-second graphic, your 1-minute graphic. And in this presentation where we actually had limited amount of time to present them, it felt very clear which were more like 3-minute graphics versus 30-second graphics, right? And so I feel that John's graphic, one can see it and is like, oh, I know what decision you're trying to make me, how you're trying to guide me through it, right? But then, our graphic on daylighting, and the very complex graphic that it feels like, oh, I wish I could have spent 5 more minutes on it, really understanding the data. Hopefully that gives everyone a sense of how your graphics actually impact who's reading them, right? And so it's not just conveying the amount of data that you've generated, but also making sure that your message gets across on the amount of time you have. And for some, you have a 30-minute discussion around it. For some, you only have 30 seconds.
Yeah, there's something I want to mention about all these graphics. And if you go to like the Building Sim conference or something, and you won't see this consistently, but you see that on all the winning graphics. They have legends that are readable. No text is too small to read. They usually have a limited number of total graphics in one graphic, 5 or 6 maybe main points. They usually read left to right pretty well. They read top to bottom pretty well. And then the question is answered by a supporting cast of all the images on there. And that's somehow that's rare in our industry to have that simplicity of thought, whether it's a 3-minute or 5-minute or 10-second, 30-second graphic.
And just tagging on to that, I just want to say thank you to the team and everyone that presented, because I learn a ton from seeing how other experts, professionals do it. And I think this has been a great resource to see that, people are often visual learners, but they can, different ways to communicate visually. And so finding ways to really impact the decision that needs to be made and who's the target audience and learning from one another has been great.
Thanks, John. I'll add a plug to Project StaSIO itself. I'm assuming most of you know Project StaSIO. You should know that you can all contribute at any time to Project StaSIO with graphics you feel have made a difference in the design process. We also have challenges that happen several times a year. And so you can also, for a particular topic, you can enter a competition and become a winning graphic, but you can submit anytime as well. So we're a community-based platform. And so without you, there are no StaSIO graphics. And so thanks to all those that have contributed, and please consider contributing yourself.
Yeah, the group formed in 2016 to try and figure out how to standardize simulation graphics. And we realized after working on it for like a year that, in fact, StaSIO stands for standardized simulation inputs and outputs. We realize that there's too many questions out there to have, like, here's how you present a daily building energy load analysis or something, or an annual or a monthly or something. There's just too many questions that to be asked to do that. So we decided instead to go with a question-based, crowdsourced format. And so of course we're dependent on the crowd of building simulation and architect professionals that are here today. So yeah, consider contributing, consider telling a friend, consider talking to people about contributing, because the more we have, the more we can look at these. We've heard that a lot of people do look through this regularly. We have hundreds of monthly visitors. I think last one was 430 unique visitors went to StaSIO last month. And sometimes when we're doing challenges or competitions, it's in the thousands. So a lot of people see this stuff, and it's a good way to be part of the community. So that's another plug for it. A question I have for all of you, if you don't have any questions for the presenters, is where is the community for this kind of thing, for thinking of simulation? We don't have like a news group or a newsletter or a message board for StaSIO, but where do you go for that kind of advice or that kind of information? We saw people just search the web for a lot of it. But if you want to talk to somebody about, like, bounce an idea off them, where do you go, or how do you get that idea?
I found Building Green Sustainable Design Leaders forum to be the main place where a lot of people who are sort of across both this and more the design side sort of pollinate. So oftentimes if I have a question, I'll ask it there.
Oh, cool. Cool. Well, we are over time, I guess. So I guess I'll stop it right there. Thanks, everybody.
One last plug, Shell, if I can. If anyone is an expert on WordPress, ping us. We're looking for someone to help. Always looking for enthusiastic people to help us out with our website. So let us know.
Yep. And how do you contact Project StaSIO? I think there's an email address, right?
Yeah, so we did not put that in there, but if you can look us up on LinkedIn and send us a message if you want. We'll do a better job at putting our email. It's vipsaprojectstasio@gmail.com if you want to contact us that way. But LinkedIn will work too.
Yep. And then this will be recorded. This is recorded, and we're going to edit it and put it on our new StaSIO YouTube account and link it into our website. So you'll start seeing videos interspersed with graphics on the website, and then you can also search Knowledge Hub, which will give you only kind of the videos and knowledge areas. So that's coming. So this will be available not immediately, but probably in the next couple of weeks. Cool. Thank you so much, everybody, and yeah, look forward to continuing the community conversations. Take care.
Great.
Thank you all.
Thank you.
Thank you.